Okay, 8.2 talks about rotations, which are another kind of transformation. And we're going to talk about rotations as being a twist. Now, they will make congruent figures. They are not going to shrink or enlarge or morph or twist our figures. We're going to, again, take our picture and move it to a new location. The way we're moving it this time, though, is by twisting it around a central point. And for us, the center of our rotations are going to be 0, 0. Later in your math career, the center might be something different, but right now it's 0, 0. We're going to talk about anchoring it at 0, 0 and swinging our figure in a direction clockwise or counterclockwise, 90 degrees, 180, or 270. And that will produce a rotation. One of the things that we can talk about when we're doing a rotation, and the way you would think about it, is here ABC has been rotated to get to A prime, B prime, C prime. How far has it been rotated? Well, for every pre-image point and every image point, you can connect and see that 90-degree clockwise rotation. And you could do the same thing by connecting B to the origin to B prime. And that is also a 90-degree angle. Now you could check the slopes of the segments and prove that they are indeed 90 degrees, but we will trust at this time that they are. Now a little side note, just to make sure that we're all on the same page. If you think about two things, here's my original figure. If I go clockwise 90, it should feel pretty good in your gut that if I went this way, counterclockwise 270, I would end up in the same spot. So we're going to have clockwise 90 and counterclockwise 270 actually are the same rule. And so we can go ahead and group those together based on the clockwise and the counterclockwise movement. The other thing I want you to think about is the fact that common sense, here my ordered pairs are positive, positive. If I rotate 90 degrees down to here, my ordered pairs are positive, negative. So I know that part of my rule is going to be changing that sign. If I rotate it to this location, I know that every ordered pair here is negative, negative. So part of that rule has to be to switch the sign. And just like if I rotate to this point, here my ordered pairs are always negative, positive. Crooked there. And so I have to think about my rule making that opposite sign. Now, rotations can start from any quadrant. I can start from the second and rotate to the first, but this is our basic idea to start with. So what are our rules? Our rule for clockwise 90, counterclockwise 270 is we take our original, and that will lead us to this. We take the x and the y and we switch their positions and we do the opposite sign on x. And I continue to say opposite sign because I don't want you to see a negative and think you're supposed to leave it. We do the opposite sign. So where would our points A and B go? Well, 0, 0 is going to stay there. 4, 1, so for example, A being at 4, being at 4, 1. If I flip-flop my x and my y and do the opposite sign, that means at 1, negative 4 is going to be A prime. That means B, which is at 2, 5, is actually going to be at 5, negative 2. And there is my triangle, which has been rotated 90 degrees. Now, if I think about 180, we talked on the previous screen that I need to somehow end up with opposite signs, and that is what the rule says. So if I take my A that is at 4, 1, A prime, I don't switch order this time. I just do the opposite signs. So 0, 0 will stay at 0, 0. So I'm talking about -4, +1 for A prime. And I'm talking about -2, -5 for B prime. And there is my triangle there. Our third rule says that I need to have the opposite sign on the y, but leave the x alone. So it's really opposite of the clockwise 90 versus counterclockwise 90. Still switch the x and the y, just do the opposite sign on the y now, which makes sense because of the fourth quadrant. So for example, A is at 4, 1. That means A prime is going to be at -1, 4. Switch the x and the y, opposite sign on the y. So -1, +4 will be A prime. B prime will be at -5, 2. And you can start to get a hint about the artwork that actually is built from translations, rotations, reflections that create tessellations and other neat patterned artwork. We have 2 quick examples for our lesson. We're going to rotate the triangle clockwise 90. So our rule, just for our reference, is y opposite of x. So t is at -2, -2. N is at -3, -4. And m is at -5, 0. When I run them through their rule, flip the x and the y, opposite sign on the x, I get 0, 5. I get -4, 3. And I get -2, 2. And if I go and graph those now, the picture should stay the exact size and the exact shape, just moved to new location. So you have kind of a built-in check if you accidentally goof up a coordinate. And t is at -2, 2. And when I sketch that in, that looks pretty good. Just for my lesson, I'm going to say, does that look like a 90-degree angle? Indeed it does. Now our next example is rotating a quadrilateral counterclockwise 180. So let's go. U is at -4, 0. J is at -5, -2. K is at -3, -3. And P is at -1, -2. I always start with the originals so that I'm sure to not make any little sign mistakes by holding too much information in my head. Now remember, our rule says just do the opposite signs. So I'm going to leave the order the same and do the opposite sign. 0 doesn't have a sign. So J is going to go to 5, 2. K is going to go to 3, 3. And P is going to go to 1, 2. Now, if you remember our common sense page, it makes sense that something in quadrant 3 should go to quadrant 1 with 180 degrees. And all of these are positive in order to be in quadrant 1. So let's go. So 4, 0 is right there. U prime. 5, 2 is at J prime right there. 3, 3 is K prime. And 1, 2 is P prime. So my figure is the same size. It's just spun. For just my own quick reference, if I check between P and P prime, that is a straight line, 180 degrees. Now before I switch, I want to quick look at the orientation of these two. So if I name this quadrilateral J, U, P, K. I'm going to do a clockwise orientation. That figure will be congruent because these are congruent. And remember when we do congruency statements, we always line up our coordinates. So they match up. J corresponds to J prime, U to U prime, P to P prime, K to K prime. That's actually easier now. But I want to go up here and look at the orientation. If I start with J and I continue this way, I am still going in a clockwise direction. So the orientation is the same. So when I get to ABCDO, I find out for 4 rotations, all are preserved.